You are now watching the 2.3 lesson video on function notation. So looking back or thinking back to 2.2, we really decided or understood what a function was. So now we're just going to take that a step further. And more importantly, when you put an x value in, you only get one y value out. That is how we know something is a function. So in exercise 1, it asks to basically evaluate. So for each of the given functions, we are given an input and we have to get an output. And we can tell that it's an input, well, because it's this value right inside the parentheses. So a lot of times people mistaken this notation for f times 2, and that is not the case anymore. F of 2 means put in 2, and let's see what we end up getting out of the entire function. So anytime we see an x on the right-hand side, so 3x plus 7, we're actually going to put in a 2. So 3 times 2 plus 7. So 6 plus 7 ends up being 13. So this is our input and this is our output. And remember, some people like to think that we can keep going further and farther, but we can't. This is done. We aren't going to multiply both sides or divide both sides by 2. That's not what that means at all. This just means the point 2, 13, is on the graph of this line right here. Okay, let's do the same thing with negative 3. So we're going to evaluate f of negative 3. That's what this means. And that means we're going to substitute in negative 3 for x. So 3 times negative 3 is negative 9, plus 7 ends up equaling negative 2. So the point negative 3, negative 2 exists on this line also. Now in part B, we have a brand new function. So we have g of x is equal to x minus 6 all over 2. And g of x is the same thing as y. So this is just y, this whole thing here. I could cross it off and put y in its place if I want to. But the reason why we show it this way is so we can actually see the input and the output together as one. So we're going to do 20 minus 6 all divided by 2. And since 20 minus 6 is 14, 14 divided by 2 is 7. You could actually type this right into your TI Inspire calculator. It would actually do all the calculations for you. So please don't make mistakes with computation. Your calculators will be your best friend, especially if you still are iffy on integers. Okay, g of 0, that means we're going to put in 0 for x. So 0 minus 6 is negative 6 divided by 2 leaves us with negative 3. So when x is 0, y is negative 3. When x is 20, y is 7. Okay, let's move on to c. c, we're dealing with some square roots here. So 2 times 4, there's our input, plus 1. So 2 times 4 is 8. 8 plus 1 is 9. So we're evaluating the square root of 9, which is 3. Or positive or negative 3, but let's just leave it plain old 3 for the time being. You can put this out in front if you like, but I'm more concerned that you know how to substitute and simplify. And again, you can use your calculator. So 2 times 0 is 0 plus 1, which is a square root of 1. Oops, let's just write that as 1, or positive or negative 1. So let's recall that y and f of x are exactly the same. So y and f of x are the same. X is the input, but f of x is the output. In exercise 2, it gives us a function f of x is equal to x over 3 plus 7. So what does the rule do to convert the input to an output? So remember, we're dealing with x. what's happening to x. That's basically what part A is saying. Well, we're dividing it by 3, then we're adding 7. Okay, next, part B wants us to evaluate, and that should say f of negative 9. There was a typo there, so let's write in the f of negative 9. So f of negative 9 is going to equal negative 9 divided by 3, and then we're going to add 7 to that. So f of negative 9, I can just copy paste. This is another way of writing it like what we did up above. That's all we're doing. So negative 3, or negative 9 divided by 3 is negative 3. And then we'll add the 7. So this just simplified to that when we divided. And then lastly, f of negative 9 is whatever negative 3 plus 7 is, which is a positive 4. So here's another way of showing it. Now part C says find the input for which f of x is equal to 13. So remember, f of x, this whole thing is the same thing as y, and they're saying that whole thing is equal to 13. So let's be careful here. A lot of time people just get so used to putting in 13 for x. That's not what it's saying. It didn't say x is equal to 13. It said f of x is equal to 13. So that means we need to put 13 in to f of x. I'm just going to rewrite my whole function just so you can see a little bit more clearly what the heck I mean by that. All right, so let's see. F of x, this is 13. That's not 13. This is 13. So 13 is equal to x divided by 3 plus 7. And we can either solve by sorting or balancing. It doesn't matter to me. I actually prefer the sorting. So x divided by 3 I'm going to leave on that side, and then 13, and since I brought the 7 over, I'm going to do 13 minus 7, negative 7. 13 minus 7 is just 6, and that equals x divided by 3. Looks like I have to scroll down a little bit. And since x is being divided by 3, to cancel out division, I multiply, and I have to do this to both sides. So 3 divided by 3 is 1. We're left with x equaling whatever 6 times 3 is, which is 18. And I always like to write my variable on the left, so even though I didn't do that at the beginning, I'll do it at the end. Just to sum this up, when I input 18, I actually get out 13. I did that one a little bit backwards because that's what the directions asked us to do. Okay, so D. I'm just going to scroll back up just so I can see my function f of x yet again. It says if g of x is equal to 2f of x minus 1. Whoa, what in the world does that mean? Well, let's break this first piece down here because I don't know about you guys, but that seems a little confusing. Goodness, this highlighter is so wide. I think I need to make it a little bit thinner. That's a little bit better. Okay, so if g of x is equal to 2 times f of x, all right, we know what f of x is, don't we? So g of x is equal to 2 times, well, f of x, isn't f of x this whole thing, x divided by 3 plus 7? So I'm going to put that in its place. And then don't forget about this minus 1 here. Okay, this looks a little bit more manageable. Now I don't have 2 weird function notations in here. Now it's asking us to evaluate g of 6. All right, so g of 6 means that I just need to, whenever I see an x, put in 6. And I only see it one time. And I copy paste everything else. This isn't too bad. Let's just keep simplifying. You could really type this all in your calculator, but let's do some calculations. It will be fun. So 6 divided by 3, so order of operations says do what's in parentheses first, then start order of operations all over again, so we divide. Looks like we got to add here. g of 6 is going to equal 2 times, well, 2 plus 7 is 9, minus 1, and it looks like we're going to get 18 minus 1, which is 17. So that was a little interesting, but nothing that we can't manage. Just recognize what the problem is actually telling you. In this case, f of x was equal to the x divided by 3 plus 7. So we just substituted that in first to make it a lot easier to do the math that led to our answer of g of 6 is equal to 17. Exercise 3 tells us that boiling water at 212 degrees Fahrenheit is left in a room that's 65 degrees Fahrenheit, and naturally it begins to cool. So they documented all of the temperatures and recorded them in this table. As the number of hours went by, they can see, or we can see, that the temperature is decreasing. So if it says evaluate T of 2 and T of 6, that's basically saying two different things, that when the time is 2, what is the temperature? So if the number of hours is 2, the temperature was 104 degrees. And then for T of 6, that's saying when the 6-hour mark has gone by, the temperature was actually 68 degrees. Now B is a little bit different. It says for what value of h, so the number of hours. So always be careful what it's asking us for. Is T of h really the y value? So we could really cross this off and say the y value, if this is our x and this is our y. So they're saying for what x value is the y value equal to 76? And if you look up in your table, it was 4 hours. So be really careful, because sometimes the numbers are not going to be so easy. Like clearly we can tell that we're looking at the x's because it only goes up to 8, and our numbers in the y's are pretty high. I mean, 65 is the lowest number, and we can tell a difference, but it might not always be that way. Maybe this was 8, 7, 6, 5, 4, 3, 2, 1. So you have to be careful. All right, on to part C. It says between which two consecutive hours will the temperature equal 100? And I know this because T of h is my y, which is really 100. So let's look up in the table. You can see that 100 does not exist, but that's why it asks between which two consecutive hours. So where are my hours, or where is the temperature dropping to past 100? Well, it's happening here, 2 and 3 hours. And why? Well, it's because 100 falls between 104 and 85. All right, now in exercise 3, they gave us a function, y equals f of x, and it looks really weird. So you might wonder, what in the world is this? And this is what we call a piecewise linear function. Because it's just a whole bunch of straight lines, all with different slopes. That's why it's considered in pieces or piecewise. All right, let's begin. So A says, evaluate each of the following. So f of 1. Well, what does this mean? This means when x is 1, what's my y? When x is negative 3, what's my y? That should be an x. When x is 5, what's my y? When x is 0, what's my y? So x, y, x, y, x, y, x, y. What do we put in and what do we get out? So looking at the graph, if I put in 1, which is 1 on the x-axis, my y value is 1, 2, 3, 4. So f of 1 is 4. All right, let's do the next one. So this is f of negative 3. So 1, 2, 3 on the x-axis. Let's find where that graph is. Well, it looks like we have to go down 1, 2, 3, 4 spaces. So this would be negative 4. F of 5 That means we go over 1, 2, 3, 4, 5 spaces in our x-axis. Down 2 gives us a y value of -2. And f of 0 means I don't go left or right. I just stay put right here at the origin. Have to go up 2 spaces. And you might say, wait a minute, aren't these just a bunch of points written in a really weird way? And the answer is yes. Yes, you are correct. This is a point 1, 4, -3, -4, 5, -2, and 0, 2. You might say, why don't we write it like that? Well, we really will in the future. So just get the hang of this weird notation now, but off to the side, if you're really feeling ambitious and you want to write out the point, 1, 4 next to it, go for it. I don't think that that's ever a bad thing. I think this will actually help you make the connection between the input and the output. Might even help you with part B where it's saying, oh, wait a minute, they're not giving us the x value anymore. We want to find the x value because we are actually given the y value. All right, let's look at this. So a y value of 0, that means I'm not going up or down at all. I'm just staying put. Now I need to find all of the x values now when y is 0. Well, that means, you know what, I'm going to highlight this line. I think this is going to help us to see this a little bit better. All right, so here is my y value of 0. So as you can see, we have quite a few x values. We have 3 x values where this is happening. We have an x value here at -1, 1, 2, 3, 4, 5, 6, 7. So the x values are at -1, what did we say, 4, and 7, all when y is 0. And some of you might say, wait a minute, this is not a function anymore, but that is not the definition of a function. If this had happened up here, then we'd have a problem. Then we would not call this a piecewise linear function, we'd call it a piecewise linear relation, because not every x would have its own y. But the x value of -1 has a y value of 0. That won't repeat ever again. The x value of 4 only has a y value of 0. The x value of 7 only has the y value of 0. Let's do the same thing when y is 2. That means, okay, start at the origin and go up 2 spaces. I'm going to use my highlighting feature again, just so we can see all the points when y is 2. And I guess it's not a highlighter, that's definitely a line, but whatever. Okay. Looks like it's touching here, so an x value of 0 and an x value of 1, 2, 3 to the right. So x is 0, and I know it was x is equal to 0 because I didn't go left or right on that blue line. And then x is equal to 1, 2, 3 because I had to move 3 spaces over. And our last and final question, sorry this video is going so long, it's just been so much math on here that we've been having so much fun. So C says, what is the largest output achieved by this function? What is the largest output? What is the highest output? The highest value? Looks like it's happening right here. There's the top. It's basically asking for the max. This is a point 1, 1, 2, 3, 4. This is a point 1, 4. So the largest output is 4, and the x value is 1.